Welcome to the video presentation on Sandmeyer Isatin synthesis. The isatins, highlighted here in blue, are a group of important building blocks for biologically active compounds such as spirotripostatin and spiroindolones. The Sandmeyer methodology is the most common method for synthesizing isatin. It involves reacting an aniline with chlorohydrate and hydroxamine hydrochloride in the presence of sodium sulfate under aqueous acidic conditions. This gives the isonitroso-acetanilide intermediate. The intermediate is then first treated with strong acid, then with water to give the desired isatin. The advantages of the Sandmeyer methodology are that it uses inexpensive starting material, it gives good yield, and it is a simple reaction. The disadvantage of the Sandmeyer methodology are that it is not regioselective, so that if a metal-substituted aniline is used as a starting material, a mixture of regioisomer will be obtained as a product. Also, the methodology does not work well for methoxy anilines. Using parachloroaniline as starting material, a typical procedure for the Sandmeyer methodology will now be demonstrated. First, 1 equivalent of the parachloroaniline with 1.2 equivalent of chlorohydrate, 4 equivalent of hydroxamine hydrochloride, and 8 equivalent of sodium sulfate are added to a mixture of water and diluted hydrochloric acid. The reaction mixture is then stirred at 55 degrees Celsius. As the reaction progressed, visible changes in the reaction mixture was observed until the isonitroso-acetanilide intermediate was precipitated from the mixture. Therefore, it is advisable to let the reaction mixture stir for a long period of time to ensure the intermediate is fully precipitated. Next, the precipitated intermediate was collected by filtration and placed under high vacuum to remove the residual water. It is important that the intermediate is as dry as possible before proceeding to the next step, or else the intermediate will fail to give the desired isatin. Dry intermediate should be flaky or powdery. The proton NMR spectrum of the intermediate in duty-rated DMSO should also show the characteristic peak at around 12.2 ppm, 10.3 ppm, and 7.6 ppm. Next, the dried intermediate was added in portion to concentrated sulfuric acid that was preheated to 55 degrees Celsius. Extra care was taken for this step, as this reaction can be violent in some cases. The reaction temperature is critical in this step. Too low and the reaction will not proceed. Too high, decomposition will occur. Therefore, the temperature was maintained between 55 to 65 degrees Celsius throughout the addition. When the addition is complete, the mixture was heated to 85 degrees Celsius for 15 minutes, then cooled slightly to 65 degrees Celsius. Then, the reaction mixture was poured into crushed ice and residual mixture was washed into the crushed ice with water. The desired isatin was observed almost immediately as an orange precipitate. The aqueous suspension was swirled until the sulfuric acid mixture was completely dissolved, and the aqueous suspension was allowed to stand at room temperature for 2 hours. The precipitated isatin was collected by filtration and placed under high vacuum to remove residual water. The desired isatin was then obtained as an orange powder with good yield and high purity. In cases where metal-substituted aniline was used as starting material, a mixture of 4 substituted and 6 substituted aniline will be obtained as the product. These regioisomers can be separated by dissolving the regioisomeric mixture in warm aqueous sodium hydroxide solution and carefully acidifying the solution with concentrated hydrochloric acid. One of the regioisomer will be precipitated first and can then be collected by filtration. Acidifying the filtrate further will result in the precipitation of the second regioisomer, which can then also be collected by filtration. And with that, we come to the end of this video presentation. Thank you.